Alright, so in this question, we're gonna go over solving more trigonometric equations. So let's start with question 5a. So we'll keep the domain in mind, which is from 0 to 360, something that we have worked with before. And 5a says cosecant x is equal to secant x. Alright, and I can rewrite this as cosecant x is 1 over sine x. And secant x is 1 over cos x. Now let me multiply both sides by sine x. So if I multiply both sides by sine x, I get this expression. And sine x will cancel out on my left hand side. So I have 1 is equal to, on my right hand side, I have sine x divided by cos x. And that is tan x. And remember, our x is between 0 and 360 degrees. Alright, so tan x is equal to 1. And if you remember, if you do x is equal to tan inverse of 1, you are going to get, in degrees, 45 degrees. Because tan 45 degrees is equal to 1. Alright, and now how do we get the other answer? Because if you remember, tan is positive in the first quadrant, and it is positive in the third quadrant. So how do we get the third quadrant answer? Well, the function tan x is periodic, and the period is just pi, right? So the other answer is going to be 180 degrees plus 45 degrees. So that gives you, and you only have two answers for from 0 to 360. So 180 plus 45 is 225. So these are your two solutions, 45 degrees and 225 degrees. All right, and we are done with question 5a. 5b says 2 sine x is equal to cos x. 2 sine x is equal to cos x. All right, very similar. So let me divide both sides by cos x. All right, so if I divide both sides by cos x, I get this expression. Or I can write it like this, which just means tan x is equal to 1. However, there is one assumption I'm making. I cannot divide by 0. So therefore, cos x cannot be equal to 0. And that means that x cannot be equal to, well, when is cos x 0? Well, cos x is 0 for pi over 2, for 3 pi over 2, right? For 5 pi over 2. So basically, it's 2n plus 1 pi over 2. Cosine cannot be an odd multiple of pi over 2. If it is an odd multiple, so if you can just take your calculator, like cos 270 degree, which is 3 pi over 2, that gives you 0. Cos 540, not 540, because 540 is a multiple of 180. Cos, say, 90 is 0, cos 270 is 0, cos 270 plus 9 plus 180 should also be 0, right? So basically, any odd multiple. So like 450, any odd multiple of pi over 2, that gives you cos x is equal to 0, right? So x cannot be odd multiples of pi over 2. All right, so we are solving for tan x is equal to 1 over 2. Right, so tan x is equal to 1 over 2, and we are solving this. So x is going to be tan inverse of 1 over 2, and that gives you x is equal to, in degrees, because we're working with degrees, I believe. So tan inverse of 0.5 is 26.5650 ... And for degrees, we're working to one decimal place, if you remember. So 26.6 degrees. And the other angle is going to be 180 degrees plus 26.6 degrees. Because the period of tan x is pi, right? 180 degrees. So the other angle, the other solution is 206.6 degrees. All right, so these are your two solutions, 26.6 and 206.6. All right, so those are your two solutions. And we are done with part B. Let's do part C. Oh, sorry. So C, the question is incomplete. So we're just going to skip and do D. So we have 3 cos 2x. Sorry. So 3 cos 2x minus 4 sine 2x is equal to 0. All right, so I can write this as 3 cos 2x is equal to 4 sine 2x, and keep the domain in mind. Keep this domain in mind. All right, so if I divide both sides by cos 2x, I get this expression. So I just divided both sides by cos 2x, and I get the expression tan 2x is equal to 3 over 4. And there is this assumption. If I divide by cos 2x, I'm assuming that cos 2x does not equal to 0. And that means that 2x does not equal to an odd multiple of pi over 2, for n is an integer. So that means that x is not an odd multiple of pi over 4, because I have to divide by 2, right? So x cannot be an odd multiple of pi over 4. That is something we need to remember when solving this. So let's just say, now 2x can be tan inverse of 3 over 4, right? And what is tan inverse of 0.75? That is 3 over 4. That is 36.86. So 36.9 degrees to 1 decimal place, right? And I'm actually going to write the whole thing. So 8698.9765 degrees. All right. And again, that is one solution. 2x, because we're working with 2x here, the angle can also be 180 degrees plus 36.86989765, because tan is periodic with pi. So the other solution is 180 plus the answer that we got. So that is 216 degrees, 0.8698976. And now this is 2x. So we're going to have to solve for x. So if you remember, x was between 0 and 360 degrees. So if it's 2x, we can actually go up to 720 degrees. So we can try, because we're working with 2x, right? This answer plus 360 degrees, we can go up to 720. So we can also add, and if you remember, 720 is tan is positive in the first and the third quadrants. 360 is one round. Another round would be another 360. 360 plus 360 will give you 720. So basically, we hit the first quadrant 2 times, and we hit the third quadrant 2 times. So another solution is just going to be 360 degrees plus our first answer, 36.86. Because if 36 is here, then adding 360 brings it back here. 2 pi rotation will bring anything back, right? So 36.86989765 degrees. So that is 396.8698977. And finally, our answer can be this plus 360, right? 216.8698976. So we can add 360 to both our answer, and it will still be within 720. So our final answer is 576.8698976. All right. And now that we have our 4 answers down, let's figure out what our x is. So from this, we know that x is going to be 18.4 degrees. So I just divide by 2 on both sides. From this, x is going to be 108.43, so 4 degrees. From this, x is going to be 198.4 degrees. And from the final one, from this, x is going to be 288.4 degrees. So these are your 4 solutions that are valid here. All right. So this was 5D. Yeah. So 18.4, 108.4, 198.4, and 288.4 degrees. All right. So we are done with D. So let's do question 6. So we are asked to solve, for sine 2x plus 0.3. So this is going to be in radian, minus 5 cos 2x plus 0.3 is equal to 0 for 0x pi. So let's just say that 2x plus 0.3. So we are working with this. So let's look at the inequality in terms of that. So if I have the inequality in terms of 2x, it's going to be this inequality, right? I just multiply everything. And now if I add 0.3 to my inequality, I get something like this. And this I'll just rename to be u. So u is bound between 0.3 and 2 pi plus 0.3 is just 6.5831 dot 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 dot. So this is the inequality that we are going to look at. All right, so now let's write this in terms of our new variable u. Right, and now I can write this as 4 sine u is equal to 5 cos u. And if I divide by cos u on both sides, I get 4 tan u is equal to 5. And tan u is just going to be 5 over 4. And now there are values. So you can say that cos u does not equal to 0. And u therefore cannot be an odd multiple of pi by 2 for n an integer, right? And therefore u is just 2x plus 0.3 equal to... And you can simplify, you can find the values that x cannot take, but usually it's not going to interfere. So you can do it on the side if you think it's necessary, but we can work with this. So tan u is 5 over 4, I think. Yes. So now u, the first solution, because this is positive, and let's just see. All right, so u is tan inverse 5 over 4. So tan inverse 5 over 4 gives us, okay, we are going to have to work in radians because we're dealing with radians. Tan inverse 5 over 4 is 0.896 radians. All right, so that is one value of u. And let's check. Does it satisfy this inequality? Yes, it does. Now, the other value that you can take is that we add, because tan is periodic. We're working with tan, and we can add pi radians, right? Because it's periodic by pi. Its period is pi. So if you add pi, you get 4.03. So 0.4 to 3 significant figures radians. So let me write the whole expression because we have a lot to simplify. 0.553846. And this gives us 4.037648038 radians. All right, so let's check another answer. We have checked our first quadrant answer. This is the first quadrant. This answer is in our third quadrant. And now our next answer is going to be 2 pi plus, right? It's going to loop back in our first quadrant. So 2 pi plus 0.8 and 8 something, 896, dot, 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 dot. But if you think about it, 2 pi plus 0.8 is going to be much bigger than 2 pi plus 0.3, right? So this is not going to be a valid solution. So you only have 2 solutions here as well. All right, so now 2x, u was just 2x plus 0.3 equal to this ugly thing, and 2x plus 0.3 is equal to this ugly thing. And now I am not going to solve it. I'm just going to give you the values of x directly. So if you solve this equation, you are going to get x is equal to x is equal to 0.298 radians. And if you solve this, so I'll let you fill in the dots by yourself. You are going to get 1.87 radians. All right, so those are your 2 solutions for question 6. So 0.298 radians and 1.87 radians. All right, so we are done with 5 and 6. So now, unfortunately, we can't do all the questions here. So I'm gonna pick some of the ones that I feel are tricky, and we're gonna go ahead and solve them. All right, so we have sine x, so 7a And we are solving for in degrees, so just set your calculator in degree mode. And yeah, so we're working 7e says sine x times cos x minus 60 degrees is equal to 0. So now, the product of two things is equal to 0. All right, so possibility 1 is that sine of x is equal to 0. And when is sine of x is 0? Well, x can be 0 degrees. It is 0 for 180 degrees. And it is 0 for 360 degrees. And this just comes from knowing your sine graph, right? Sine is 0. At 90, it is 1. At 180, it's 0 again. At 270, it's -1. And at 360, it's 0 again. So for these three angles, sine x is equal to 0. All right. And now, possibility 2 is that cos x minus 60 degrees is equal to 0. And when is cosine 0? If the angle inside, which is x minus 60 degrees, cosine is 0 at when it's 90 degrees, when it's 270 degrees, and so it's only 0 twice, right? It's only 0 at 90 and 270 for between 0 and 360. But we can always check. Okay, I think these two are it, to be honest. But we can always go for one more odd multiple. And the next odd multiple is, I think, 540. Right? So if you draw your cosine curve, you'll see that cosine 540 is also 0. Sorry, not 540. So it's going to be 270 plus 180, 450. All right. So now, x can be 150 degrees, right? X can be 330 degrees. And if you see that, if you solve for x here, you are going to see that it's going to be much greater than 360. So we're just going to exclude this one. So you have 5 answers. X can be 0, 180, 360, 150, or 330 degrees. All right. 0, 180, 360 degrees, and 150 and 330 degrees. So this one is, if it's not clear, it's 150 degrees. All right, so these are your 5 solutions for 7a. Let's look at 7b. So if you have these types of question, right, how do you solve for sine x? Well, let's work with this. 5 sine squared x minus 3 sine x is equal to 0. And remember your domain. So let me just factor out a sine x. I have 5 sine x minus 3. So either sine x is equal to 0. And if sine x is equal to 0, we already know for 0 to 360, we know that if x is 0 degrees, 180 degrees, or 360 degrees, sine x is going to be 0. All right. So we have immediately solved for 3 angles. The other possibility is that 5 sine x minus 3 is equal to 0. And that just means that 5 sine x is equal to 3. Sine of x is going to be 3 over 5. So sine of x is positive. When is sine positive? In the first and the second quadrant. So we are going to have 2 answers. So if the first answer, the acute answer, is going to be sine inverse of 3 over 5. So if you do that in your calculator, you get 36.9 degrees to 1 decimal place. And the other angle, if you've watched the previous video, you know that you can get by doing 180 minus the first angle. And that angle is going to be 143.1 degrees. So these are your 5 solutions. So 0, 180, 360, 36.9, and 143.1 degrees. All right. So that is how you do B. C can be done in a very, very similar way. So we have tan squared x is equal to 5 tan x. So we bring everything to one side. So we have tan squared x minus 5 tan x is equal to 0. And let's factor out a tan x. If you factor that out, you get tan x minus 5. All right. So now possibility 1 is that your first term, which is tan x, is equal to 0. When is tan x 0? Well, if x is equal to 0, tan x is 0. And then if x is equal to 180, tan x is 0. And if x is equal to 360, tan x is 0. Tan x, how do I know this? Well, tan x is just sine x over cos x. And it's going to be 0 whenever the numerator is 0. So the numerator is 0 for these three angles. So you just keep the same three angles here. Now, the other possibility is that tan x minus 5 is equal to 0. And that just means that tan x is equal to 5. And you can solve, because this is a positive output, you can solve for the two values. So the first value, the acute value, is going to be tan inverse of 5. And tan inverse of 5 is just 78.7 degrees. And the other value, if you've watched the previous video, you know that you can get by adding 180 to this acute angle, because you want to send it to the third quadrant, right? And if you do so, you get your final answer to be 258.7 degrees. All right, so those are your solutions. So 78.7, so 0, 180, 360, 78.7, and 258.7 degrees. All right. So part D is very similar as well. You have sine squared x plus 2 sine x cosine of x is equal to 0. All right, so you can just factor out a sine x. If you factor out a sine x, you get sine x plus 2 cos x. So the possibility 1, again, is that sine of x is equal to 0. And you already know that your three solutions automatically should be. So if you're multiplying by two things and it gives you a 0, it's possible that the first thing is 0 and sine of x is 0 for 0 degrees, 180 degrees, 360 degrees. And the second possibility is that your second thing is 0. So sine of x plus 2 cos of x is equal to 0. Sine of x is equal to negative 2 cos of x. And if I divide by cos of x on both sides, I get tan of x, sine divided by cos is tan, is equal to negative 2. So let's take tan inverse of negative 2. And if you watch the previous video, you know that I am going to get a value that is a negative angle, but we're solving between 0 and... So if I do this, I get negative 63.4349, so negative 63.4 degrees. And this tells me that tan of the positive version of this angle is going to give me positive 2. All right, if I have the acute angle, so how I know this fact from this, if you've watched the previous video, you will understand how I can go from this part to deduce this part. All right, so I know that tan 63.4 degrees is 2. I have the acute angle. And if I know the acute angle and the value, I know I just need to put this acute angle into the right quadrants where tan is negative. Tan is negative because tan, remember, tan is negative here. So tan is negative in the second quadrant and in the fourth quadrant. So your first angle is just going to be in the second quadrant. So 180 minus your acute angle is going to be one solution. So your one solution is just 180 degrees minus. So you just need to ignore this. Do not write this in your exams, all right? So your first solution, so you just know to deduce that, okay, negative 63.4 is the acute angle I need. So your first solution is in the second quadrant, so 180 minus 63.4. And your second solution is in your fourth quadrant, so 360 degrees minus 63.4. And if you do so, you get 116.6 degrees. So if you use the whole thing, right? If you use the whole thing, 63.434, whatever, and if you add it to 180, you get this expression. And so 63 is not just 4, it's like 439,482 degrees. So you get 116.6 degrees. And the other solution, so if you use the whole thing, you're going to get this. So your solutions are 0, 180, 360, 116.6 degrees, and 296.6 degrees. All right. So we are done with part D. So the solutions are only the ones that I have highlighted. All right. So part E tells me 2 cosecant x secant x is equal to 2 cosecant x. Now we are more comfortable with working with sine and cosine, so let's just write this as 2 divided by sine x cos x, because this is just 1 over cos x, 1 over sine x, is equal to 1 over sine of x. And if I multiply both sides by sine of x, I get 2 over cos of x is equal to 1. And this tells me that cos of x is equal to 2 if I multiply by this. If you remember, cosine of x is bounded between positive 1 and negative 1, right? So it cannot be equal to 2. So there is no x, no solution, because cosine of x is always going to be between negative 1 and a positive 1. So for E, you have no solution. All right. For F, we have sine of x tan of x is equal to 4 sine of x. I know that it's tempting to just cancel these things out, but you are going to miss some solutions. So to get all the solutions, let's bring everything to one side, equal to 0. And now we can factor out sine of x. And we get this expression. So first possibility again is that sine of x is equal to 0. And we already know it's going to be 0 for 0, 180, and 360 degrees. For this domain, remember that I'm working with this domain. So for this domain, I have 3 solutions. 0, 180, 360, satisfying sine of x is equal to 0. And the other possibility is that my second term, tan of x minus 4, is equal to 0. We just mean tan of x is equal to 4. And x is going to be tan inverse of 4, which is tan inverse of 4 in degrees is just 76.0 degrees. So if you round off, or to 2, it's going to be 76.96 degrees. So I'm just going to round it off to 75.96 degrees. So I'm going to round it off to 76.0 degrees. All right, so that is one solution. And if you watched the previous video, you know that you get the other solution by just adding 180 to your acute angle solution. So your other solution is just 255.96. All right, so those are your solutions. So 255 point, you can even say 256.0 degrees, or 255. All right, so I'm just rounding off to 1 decimal place. But yeah, so 0, 180, 360, and 75.96, and 255.9. So yep, these are going to be your solutions. All right, so we are done with part F. Now question 8, I'm not going to go through all of them, maybe as much as possible, and hopefully quickly. So we have 4 cos squared x is equal to 1. Cos squared x is 1 over 4, right? Now, cosine of x can be plus or minus 1 over 2, right? If cosine of x is positive 1/2 and you square it, you still get 1 over 4. And if it's negative 1/2 and you square it, you still get 1 over 4. So this is something that we already have discussed when we worked with. If I say x squared is 1 over 4, then x is equal to plus or minus the square root of 1 over 4, right? So it's plus or minus 1/2. So we're going to use the same logic here. All right. So when is cosine of x? So first possibility, when is cosine of x positive half? And if you remember, cosine of x is positive half for when x is equal to 60 degrees, which is pi over 3. And to get the other solution, you just do 2 pi minus pi over 3, right? So 2 pi is just 6 pi over 3 minus pi over 3, so 5 pi over 3. So these are your two solutions, pi over 3 and 5 pi over 3. And the other possibility is that cosine of x is negative half. And cosine is negative when it's in the second quadrant and in the third quadrant. And we know our acute angle, 60 degrees. So if we know our acute angle that gives half, if it's positive half, then we can quickly find the angles at which I get negative half. Well, one of the angles is going to be pi minus pi by 3 in the second quadrant. And the other angle is going to be pi in the third quadrant, pi plus pi by 3. So I'm going to get 2 pi by 3 and 4 pi by 3. So my four solutions are pi by 3, 5 pi by 3, 2 pi by 3, and 4 pi by 3. Am I working with degrees? Okay, sorry. I'm so sorry. I'm working with degrees here. So this is 60 degrees. This is 120 degrees. This is 240 degrees. And this is 300 degrees. So those are going to be your solutions. 60 degrees, 300 degrees, 120 degrees, 240 degrees. All right. So that is how you do A. Okay, if things are clear, I'm going to erase this and we move on to B. For tan squared x is equal to 9. And I can write tan squared x to be equal to 9 by 4. Tan of x is going to be plus or minus the square root of 9 by 4. Right? Again, whether you square the positive value or the negative value here, you're going to get the same answer, right? You're going to get 9 over 4. So your answer is plus or minus 3 over 2. Possibility 1 is that tan of x is equal to positive 3 over 2. And you can get x by taking the inverse tan. And x, if you do tan inverse here, you get 56.3 degrees. That is one solution. And if you know the acute angle for which you get 3 over 2, to find the other solution, you just add it to 180, right? So that in the third quadrant, it's positive. So the other solution is just 236.3 degrees to get positive 3 over 2. Now the other possibility is that tan of x is equal to negative 3 over 2. And we know the acute angle for which we get positive 3 over 2. So we're just going to use that. So x can be either in the second quadrant. And to get to the second quadrant, I'm going to subtract this angle from 180. And that gives me 123.7 degrees. And if I know one angle, because tan is one angle for which I get negative 3 over 2, the other angle is just going to be periodic. It's just going to occur periodically. So I just need to add 180 to my answer. So it's just 303.7 degrees. So my four solutions are 123.7, 303.7, 236.3, and 56.3 degrees. All right. So these are our solutions for B. C is quite straightforward as well, so I'm going to leave C to you. It's very similar to A. So D is quite straightforward as well. It just tells me that 1 over cos squared x is equal to 9, which implies that 1 over 9 is equal to cos squared x. And therefore, cosine of x is equal to plus or minus the square root of 1 over 9. And that cosine of x is equal to plus or minus 1 over 3. All right, so the first possibility we're going to consider is that cosine of x is positive 1 over 3. So if I take the cosine inverse, I am going to get the acute angle, which is 70.5 degrees. All right, and if I know the acute angle, the other value automatically will occur in the fourth quadrant. And to get there, I know I just need to subtract this from 360. All right. And that is going to be 289.5 degrees. So I already have two solutions, 70.5 and 289.5. Now I need to solve for cosine of x is equal to negative 1 over 3. And I can again just take the cosine inverse. For cosine, I don't really have to think about. I don't really have to worry because I am going to get an obtuse angle. I'm going to get an angle in the second quadrant. So 109.5 degrees. So that is one solution. And to get my another solution, I can again subtract from 360. Why? Because remember, cosine of x is equal to cosine of 360 minus x in degrees. All right, so 360 minus this value gives me 250.5 degrees. All right, so we have our four solutions: 70.5 degrees, 109.5 degrees, 250.5, and 289.5 degrees. All right, so we are done with D. Part E. We have cot squared of half of x is equal to 4 over 9, right? So I just divide by 9 on both sides. And remember, x is between 0 and 360 degrees. So if it's half of x, which is x by 2, I'm going to be between 0 and 180 degrees. And I'm going to replace x by 2 with u. All right. So cot squared u is equal to 4 over 9. And I know that tan squared u is going to be 9 over 4. And I'll leave you to figure that out, because cot squared u is just 1 over tan squared u. And by by basic simplification, you're going to arrive at this expression. And tan u is going to be plus or minus the square root of 9 over 4. And the square root of 9 over 4 is just 3 over 2. All right, so case 1 is that tan of u is equal to 3 over 2. And u can just be the tan inverse of 3 over 2, which is going to give me an acute angle. And that is just 56.3 degrees, which is between 0 and 180, remember, because u is just x by 2, right? And my other solution is just 180 plus 56.3, right, for u. But I can't add 180 because it's going to exceed, right? It's going to go above the limit. So I don't really need to work with that. The other possibility is that tan u is equal to negative 3 over 2. And now for this one, if I know that tan 56.3, I know that tan 56.3, I know the acute angle, basically, that gives me 3 over 2. So if I know the acute angle, then I just need to think, when is tan negative? Tan is negative in the second quadrant, so 180 degree minus 56.3 degrees, right? So that gives me u is equal to 180 minus 56.3. And if you think of the other solution, so this is just 123.7, it's not going to satisfy the inequality that of u. So we only have two solutions, 56.3 and 123.7. However, remember, u is x by 2. So if you need to solve for x here, so you need to multiply 56.3 times 2. And that gives you 112.6 degrees. And this is, again, x by 2. So x is going to be 247.4 degrees. So we have two solutions, 112.6 and 247.4 degrees. All right. We're done with E, and I'll leave you to try F on your own. It's quite similar to D. All right. And we are done with part 2. And we'll have one more part to cover the whole chapter.